is a team. Take a look at this bridge design. The first one, Edmund Bridge, Kumamoto, Japan. Second, Francis Scott Key Bridge, Maryland at US. And the last one, Victoria Bridge at Perak. Can you spot the similarity of this bridge apart from the function connecting two points? Yeah, something related to the design, which is efficient structural system and easy to analyze, called truss. In this video, I'll be talking about the overview of the bridge design purpose. Now, moving on to the truss introduction. The truss is a structure made of individual small members pinned together where each members only take tension or compression forces. In truss, you can build up large and strong structures with small and fairly weak individual parts trusses. There are a variety types of truss designs such as Warren, Pratt, Howe, and K-truss. In this project, the Warren design used in Ponte-Cordes, France, is utilized in the design of this bridge. Best used for the structure that have a longer span. Moving on to design of bridge. In designing the bridge, we have generated a design by using Step Reconnect V22. The bridge is statically indeterminate, and the loading and modeling specification is as shown. 3D models is provided in this project to improve the design quality based on the output used to generate the design of bridge. The material of the beam is steel. This is the bridge elevation plan to show the appearances of the building from different angles of view.
For internal force, the real load. My name is Nur Fatma Zahra binti Kamsun. The calculation for real load is by using the alternative method. This method is the easiest way to obtain force in each members. It has the same concept from method of joint, where all the loads need to be assumed moving outward from the joint. And in order to use this method, there must be most two unknown and at least one known force. From the free body diagram earlier, at point F, the Fy is 25 kN upward. Calculation for real load. 25 kN divided with the height of isosceles triangle, which is 1.732 meters. N is equal to x, where x is the direction of x. In member of Fg, the value of x is 28.86 divided by 2, as it is an isosceles triangle. To obtain the force of Fg member, 25 kN squared added with the x direction value of member, which is 14.43 squared. The total of this answer will be the square root, so the force of Fg member is 28.86 kN in compression, as we assume all the force move outward the joint. Proceed the same step as earlier to complete the calculation of all force in the members of the bridge to obtain the real load.
Okay, Assalamualaikum. My name is Nurul Aisha and I will explain the next calculation, which is virtual load calculation by using virtual work method, or we can call it as work energy method. So what is actually means of virtual work method? It is actually uses the law of conservation of energy to obtain the deflection and slope at a point in a structure. Why exactly we apply this method on this truss? It is because the type of truss is determinate structure with zero determinacy. Okay, let us proceed to the process of calculation. First thing first is to find virtual force. To find virtual force, we have to place 1 kN load on the truss at the joint where the desired displacement is to be determined. The load should be in the same direction as the specified displacement, either it horizontal or vertical. So all real load is removed from the truss and then calculate the internal force in each member. Next is to find real force. To find real force, we have to use any method to determine the end force in each member, which is method of joint, method of section, or alternative method. These forces are caused only by the real loads acting on the truss. Okay, lastly is applying virtual work equation. So the formula as shown in the slide. If the resultant sum is positive, the displacement is in the same direction as the unit load. But if the resultant sum is negative, the displacement is opposite to the unit load. Okay, let me show the calculation of virtual load for our truss bridge. First step is to calculate the virtual load, which is we have to apply 1 kN load at joint that desired displacement, and in this case we apply it on joint I. After that, we calculate the reaction of the external support, which we found at pin support A, the vertical reaction is 0.5 kN and the horizontal reaction is 0 kN, while at roller support at joint F, we found the vertical reaction is 0.5 kN. After we identify the reaction, we calculate the internal force of virtual load using alternative method, and the result as shown in the slide. And for other two procedures, we already calculate on real force calculation explained by Fatma, and applying the virtual work equation will be explained by Joyce Inya.
Good day to everyone, my name is Joyce Inya Joss, and for today I would like to explain regarding the analysis of deflection that we have done towards the design of our bridge. To identify the deflection of bridge, we have inserted our model inside of a software application which is LinPro, which is used to identify all the values that we needed for the identification of deflection. However, the significance in this deflection of bridge is that LinPro could not identify the area and as well as the Young's modulus, which is E of the beam. Therefore, based on the deflection of bridge, the way that we conclude is by looking at the diagram of the deflection. So, based on the diagram of the computer aided, we have found that the beam is pointed downward. So, it shows that the deflection of bridge is downward. Next, to make sure that our calculation is accurate, we have used the calculation of deflection manually, which is shown in this slide. Based on this slide, we have computed all the values inside of a table to ease our findings in F and L. So based on the table, we have found the length of each member, the force of each member, which is the real load indicated as F, as well as the virtual load, which is N. So if we times all the value, we can find the F and L value, which will be used inside of the deflection calculation manually. Based on our findings, we have found that the model indicates a 620.34 kilonewton square per millimeters over AE, which indicates that the model is having a downward deflection. So, in conclusion, we have discussed regarding about the manual data and also software data in a table shown in this slide. Based on the slide, we have found that the reaction of manual data and software data is the same, as well as the internal force, which is the same. But for the limitation of our study, for the deflection, we only referred to the diagram of software data towards our manual calculation. Although we could not find the value of AE, we have found that both manual data and software data shows that the deflection is pointing downwards. Not only that, we have also concluded that our design should have improvement for the future, for example, by using high quality materials for each connection in the members, and also by using larger cut depth or thickness in the material of the elements to increase high bearing ratio and also increase the strength of the design. That's all from us. Thank you.